Hey guys, it's me again. In today's video, I just want to actually showcase a repair that I completed a little while ago, or a couple days ago, I should say, actually. Unfortunately, I didn't have the chance of filming it and stuff. This was a little bit of a tricky repair. This is a 3 kilowatt inverter and battery charger, as it says here, obviously on the top. Yeah, 3 kilowatts, and it can sustain 20 amps on 12 volts DC. Basically, this is some whatever, I guess some Chinese company or something. I don't know, Royal Power. Um, but basically, I can show you a quick look around, I guess. In the this is the front side, I guess they call it. We have 4 AC ports, so you can plug in your devices that you want powered off this thing over here, and it's it says 115, but it's 120 volts AC, 60 hertz. And on the front as well, we have a display over here that shows the current consumption and the voltage of the battery when the unit is in inverter, when the unit is in inverter mode. We have the option of having a it's like a dongle that plugs in here, and it acts basically, you can control it wirelessly with a remote, the handheld remote. We have our on and off switch, and then we have the selection for the screen, and we can display the volts or the watts of we can display the draw that we're pulling from the battery, and we can also look at the voltage of the battery. And we have 2 LEDs here that show us some statuses of the unit when it's in operation. And then the back side, we have the positive leg, the negative leg of this massive inverter. And we have a fan. This is a 12 volt DC fan that provides some cooling. And then we have our mains input, which is over here, that runs on 120 volts. And we have a lug to tie to ground if you want to tie this to a copper pipe or any sort of ground. But yeah, basically the issue of this unit, there was a couple of issues. The first issue, well, the main issue was it would not work on the charging mode, or basically whenever the mains AC was plugged in, the unit would kind of just like shut down almost in a way. The lights would come off, everything would just basically come off, and the unit seemed dead. The only thing that worked was the inverter mode. So when you flip the power switch, and if you only had the battery connected, then this worked without a problem. So the issue came down to a couple of things. The first of which, we have our classical faulty capacitors. These were all the caps that were changed. Some are evident that they failed. Well, actually, one of them is evident that it failed. I think it's this one right here. If you look at this guy, we can see that the top of the capacitor is bulged, so it's rounded off on the top. And if you want to put it on a flat surface, and if you look carefully, you can do something like this with it. Yeah, no good. So this was obviously defective. It's a high quality Chinese company called Glucas. Never heard of them before, so must be really good, I guess. 2200 microfarad, 25 volts, rated for 105 degrees. So I'm not surprised this thing failed the way it did. Anyways, so that one was replaced, obviously. Then we have these other ones here that don't seem like they failed. As you can see, the top, this one doesn't do the same wobbly dance as this guy over there. So the top is pretty much good. It looks like it's okay, but when I tested it with my ESR meter, this showed, I don't remember exactly, but one of them showed actually a really, really high reading, like 8 or 9 ohms. So they were definitely bad. And we basically, all of these ones were testing bad. They were throwing a high ESR reading, and these all look good, just like this one. But again, because of the high ESR reading, they were changed. So yeah, so the first issue was we had issues with faulty electrolytic capacitors. The second issue was we had broken connections on one of the boards inside here, actually, and it was the control, not the control board, it was the board that handled the mains AC voltage over here. So when you plug it in, there's a wire that goes inside and it connects to a board. That board had a lot of broken connections on there, broken solder, whatever. So that was all tidied up and addressed. And then the last issue, believe it or not, on that board and the control board, so the board that had the AC stuff on there and the control board, which I believe also monitors and charges the battery accordingly. The main and the control board, they had glue on there that basically was shorting some connections out. So for some reason the glue, it turned into a conductive material and shorted some connections out and was causing all this weird stuff to happen. That was probably the hardest thing to find, and I should have actually been able to find it sooner, because the glue was actually, parts of it were like a dark brown. And it's not the first time that I see this happen. Actually, I see it a lot also on old stereos. Old stereos, when they came out in the 70s and the early 80s and whatnot, the factory used not maybe the same glue, but a similar glue to hold components in place. And the problem with that glue is, over time, it tends to change properties from going to from a glue to basically a conductive material, and causes things like this to happen, where all of a sudden things just randomly die and don't work like they're supposed to. So I used actually this very same tool, my pick over here. I removed all of the glue and it brought the whole thing back to life. So, but it was a combination of those three, because I was doing my testing with my meter and, things weren't right, and I was solving, like, first thing I fixed, okay, then there was another problem, and then there was another problem, and so on and so forth. And it got to the point where, yeah, there were 3 issues in total, and they were pretty much taken care of. And now the customer, I put it all back together, and he has a working inverter, charger. Inside this, I wish I really filmed this, but just a picture inside this, there's a couple of boards. There's a total of 3 boards. There's the AC board that takes the 120 volts in. There's a control board about over here that monitors and charges the battery accordingly, and also, I guess, monitors the output, whatever, and controls the display over here. And on the bottom, there's one big ginormous board that contains all the transistors and transformers that convert the 12 volts DC to 120, and then 120 to 12 volts and whatnot, whatever. So taking this apart was not fun, and testing it was not fun, because to test a unit like this, it turns out everything has to be pretty much connected. You cannot really reliably test it without connecting all the boards and doing basically the test or whatever, So I had to kind of arrange a weird way on the table here to have it like sandwiched open. So basically having one part here and another part here, and then basically just connecting with some jumpers and whatnot if the cables were too short to do the test. And I managed, and I was able to test it. But now what I want to do is I'm going to hook up a battery to the output over here. And we're going to plug in the AC mains and everything. I'm just going to show you a demonstration how this is working now after the repair, and we'll even put a load on here just to test to make sure. So I'm just gonna grab a battery, hook it up quickly, and we'll do that test. Okay, so we have pretty much everything hooked up now that we need to. I have even my multimeter hooked up, and the front we don't have a load connected yet, because I cannot run the load off the source that I'm connected right now, because it's not going to be able to handle all the power. So we will run it off the battery, but I know if I plugged it into our normal mains, it would work no problem. We have our 12 positive and negative leads hooked up in the back, including the mains right there, as you see. And I'm using a little 12 volt lawn tractor battery, and it's gonna do fine. Right now we are reading 12.81 volts DC, so that's the 82 it says now on the voltmeter for the battery. I'm going to go ahead and flip the switch on. You're going to notice the red light should come on and stay on because the battery is charging. So we're going to flip it on. The green shows up quickly, but it's going to change to red as you see. The relay clicked, so that means we are getting power off over here. And we can also check that to see that the battery is charging, and as you see, we are reading now 13.58, almost 14 volts DC. So this is now, the unit is charging the battery. And if we go to the front, it switched to green because the battery is fully charged. I already had this hooked up for a while to test it out myself, and the battery was fully charged, no problem. So when the battery is charged, the green light comes on and there's nothing on the display. You plug in all your devices, you know, whatever, and you have no issues there. And then when the battery is dead, this will change to red, as you saw before, and the battery will be charging up. We're gonna go ahead and do a test now. I'm gonna hook up my drill, which pulls about 5 amps. Again, I can't run it off here because it's gonna basically pull a bit too much power, because this is connected to my isolation transformer, and the isolation transformer cannot handle that much power. So I'm gonna do basically the test as if this was an inverter, and you'll see it running, and you know, no problems. All right, so slight change of plans. I will do the test actually with the isolation transformer, but instead of using my drill, I will be using my fan. And as you may hear already through the microphone, the fan is running at full speed, highest amount of power that it can possibly draw. And as you see, this wire goes from here, goes all the way around back to where the fan is. So it's plugged right now, the fan is plugged right onto this inverter charger. We are reading, again, 13.6. This is, for this battery, it's fully charged. So at this level, the battery is fully charged, and as you can see, there's no fluctuations. It's staying pretty much at the same point. We're gonna do now a test, a switchover test. So we're gonna simulate a power outage, I guess, because the gentleman that this belongs to, he basically has a sump pump connected to it, and he has not a long tractor battery, but maybe a deep marine cycle battery. And basically, whenever the power goes out, the sump pump is always, you know, powered up, and as long as the battery doesn't drain, the sump pump keeps working as it should. So we're gonna disconnect the mains, not literally, I'm just gonna flip off my my isolation transformer, and basically no more power is going to be coming to the unit from the AC mains, and we should see a small switchover time, because it doesn't go straight to battery power. It takes maybe a second or two before it switches to battery power, which is normal. So the green light is on, indicating the battery is fully charged. The display is not on yet because it's still running on mains power, AC mains. We're gonna now turn off the mains, and you're gonna see, I just want you guys to watch the screen. You're gonna see now the switch over time, and you're gonna see the screen illuminate. So I'm gonna go ahead, turn off my isolation transformer. There's the switch over, and we have now the unit running on battery power. I don't know if you heard, or obviously you couldn't see because I was pointing here, but the fan turned off just for a split second, and now we're running on inverter power. So basically off battery power, and we are reading off battery power, we are reading 12.9 volts. It's dropping. This battery is not designed for this, so mind you, it might be dropping quick because of that. It's just a little tiny long tractor battery. So if I switch to volts, so basically from volts to watts, watts to volts, watts, it's not showing anything because this is measuring in amperes, amps, and this fan does not even pull 1 amp of power. It takes maybe a quarter amp, 500 milliamps of current at most, so it doesn't show up on the screen. But trust me, when you put a decent load, that's going to start coming up the numbers. But if you put it to volts, you see that we are getting basically more or less the same reading off of well, actually no, there's a slight discrepancy, I guess. 12.2, 12.5. But anyways, it gives you a rough idea. It's not maybe too precise, but it gives you a rough idea of the status of the battery. So what we'll do now is we're gonna bring it back to mains power, because keep in mind the unit's still on, but the only difference is it's running off of the battery power. So I'm gonna go ahead and turn on my isolation transformer. There's the switch over to mains power, and now basically the battery is charging. So we are reading 14 point something volts. This is all controlled by the charger. The charger decides the cycle and the curve for the charging. So it's now doing, looks like it's doing a quick charge, and now it's dropping back down, and it should be fully charged, and it is fully charged. So this, in the manual, it shows how the charger, how this charger basically charges the battery. There's a curve, and basically there's a peak charging, and then it goes down slowly to a more stable amount. So there you go. Battery, again, I used it maybe for a couple seconds, and the battery's already fully charged, so it pretty much got charged back up very fast. But yeah, there you go. So this is repaired, and the customer, he's very happy with it. It did take a bit of time, but yeah, I spoke with the customer. He's gonna pick this up sometime this coming week, and hopefully he'll have his sump pump working again like it was in the past. So if you guys like this video, please subscribe and hit the like, or the like button, the bell, whatever is down in the video bleep bloop section there, the comments, if you want, leave one there as well. But yeah, until next time, you guys take care, and yeah, I'll see you on the next one. Bye bye now.